All right, welcome everyone. I just want to thank you so much for joining us today. The webinar is entitled NutrEval, Redesigned, Reimagined, and our guest speaker is Dr. Michael Chapman. As many of you know, my name is Dr. Lenore Powell, and I'm a medical education specialist here in the Genova's Atlanta branch, and I will serve today as your moderator for the webinar. We would like to welcome Dr. Michael Chapman. Dr. Chapman is there he goes. Hi, Dr. Chapman. He is a licensed naturopathic physician who graduated from Bastyr University in Seattle, Washington. And upon graduation, he spent 3 years in private practice before joining the team at Genova Diagnostics. His area of clinical focus are hormone regulation, gastrointestinal health, and autonomic balance. Prior to medical school, Dr. Chapman earned his bachelor's degree from Indiana University with a focus in neuropsychology, and he later worked as a microbiologist performing pharmaceutical research on cancer cell lines. Pretty cool. So, for those who are still doing a lot of telemedicine, just remember we have many non-invasive urine, saliva, blood spot, stool collection packs that can be shipped directly to your patient for specimen collection at home. And the requisition can be completed totally online. For more information, just visit your MyGDX account. So, Dr. Chapman, I'm going to turn over the role of presenter to you.
Great. You know when that comes through. I got it. There we go. How's that?
Beautiful.
Yay. All right. Thank you, Lenore. It's good to see you. And hello, everyone. Thank you so much for joining us, as Lenore said. We are just so excited to be discussing the NutrEval and some of the changes, all the updates, new features that have gone into this, and got a lot to cover, a lot of different things to discuss. So I'm just going to kind of get right into it. Starting with objectives, of course, right? So here we go. Cover core concepts important to nutritional evaluation. It's always good to kind of take a little bit of a step back and say, what are some of the important things that I need to be considering when looking at someone's nutritional status? Highlight some of the enhanced clinical utility on the NutrEval, but also the Metabolomics Plus. That's important if you're using the Metabolomics Plus, kind of that awesome at-home collection, that these changes, many of them apply to the Metabolomics Plus as well. We're going to discuss additional insights that aid in clinical application, just in general, of nutritional testing, and we will go over a case study. So, first concept that I think is super important to understand when doing a nutritional assessment is the difference between a direct measurement and a functional assessment. And so a classic example of this with a direct measurement, we're talking about things like serum B12, RBC folate, where you're drawing some blood out of a tube and you're saying what was the concentration of a nutrient in that sample. A functional assessment is a little bit different. And a functional assessment is not only saying how much of that nutrient might be there, but how well is the cell using that nutrient? Are we seeing any evidence of needs for additional support? How does that relate to the biochemistry of a patient? And so we'll kind of get to the nitty-gritty of what a functional assessment looks like, but keep in mind, just as a high level, there's a difference between these two types of assessments. There's also a difference between what we consider intracellular versus extracellular assessments. And you might have heard this conversation quite a bit, but extracellular versus intracellular, sometimes people think, oh, well, an intracellular assessment is the way to go. It's what tells me the most about their dietary intake and things of that nature. But keep in mind that each nutrient is a little bit different. And some nutrients spend a lot more time intracellular, others are exchanged quite more rapidly and are free floating in the plasma or the serum. So it's not one size fits all. And really, when we're thinking about intracellular versus extracellular, we really want to know what we're talking about. And in general, the more information that you can gather, the better, which is why with the NutrEval and the Metabolomics Plus, we're looking at both intracellular and extracellular assessments. Not only are there nutritional needs that come from a test like the NutrEval or the Metabolomics Plus, but there's also information about the direct clinical application of some of these biomarkers. So in certain circumstances, we're looking at a biomarker to give us evidence for needs for a nutrient, but we're also understanding that that biomarker has direct clinical relevance too. So there's kind of a dual layer to a lot of these biomarkers, and I'll try and highlight as many of those points as I can today. And then supplement influences. We get this question a lot. How much does a supplement or a patient taking a supplement influence the results of the test? And so we always say, kind of as a general rule, if you're looking at trying to get a patient's baseline assessment of their nutrition just based on their diet alone, then maybe consider discontinuing supplementation for a period of time and then running the test. But it's certainly another way to look at it if you want to say, well, I've been having this patient take this vitamin or this supplement for a long time, and what are the results of the test of the patient on that supplement? What has changed? How does it look now? And so you can kind of run the test in two different ways and get different information. So it kind of just depends on what's the question you want to ask. So just real briefly, high level, looking at the NutrEval report, we start with this results overview and functional imbalance scores. Then the second page is dedicated to the overall nutrient need evaluations, things like antioxidants, B vitamins, and we'll go into this in greater detail. Then we get into these pages called the interpretation at a glance pages, which I spend most of the time kind of discussing the results with the patient on these pages. We have a lovely biochemistry graphic here, oxidative stress and mitochondrial dysfunction, that we also commonly and colloquially refer to as the Krebs cycle page. Then we get into the actual analytes, the actual data, the things that we directly assessed on the tests, starting with organic acids. We've got 2 pages really kind of dedicated to organic acids, followed by some oxidative stress markers that I'm sure you're likely familiar with, glutathione, lipid peroxides, things of that nature. A few additional pathways to kind of demonstrate how we're arriving at nutritional recommendations. Then the amino acids, followed by essential metabolic fatty acids. And lastly, element markers. And certainly there's options for add-ons like vitamin D as well. So let's kind of dig into each page a little bit more specifically, starting with this front page, the results overview and functional imbalances. At the top of this page, we have this results overview graphic, which provides these kind of color icons for a quick glance at functional imbalances. Really, I kind of think of this as like, how bad is it, right? How much red am I seeing, and where are the major areas for needs for support? And then we break that down a little bit further into these functional imbalance pillars, and we give these functional imbalance scores. Now, the 5 areas of function that we're evaluating on this nutritional test are oxidative stress, mitochondrial dysfunction, omega imbalance, toxic exposure, and methylation imbalance. And so what we're really trying to say is, yes, this is a nutritional evaluation, but because we know the interplay so well between nutrition, biochemistry, and clinical outcomes, these are the foundational areas that you might get evidence and need for support, right? You might get clinical understanding of a patient's oxidative stress load or their potential mitochondrial dysfunction. And so that's where these 5 pillars are ultimately coming from. And so then we have the functional imbalance scores. And this is a 0 to 10 scale. We start with this key at the top to just tell you a 0 to 4 shows up as a green, probably a minimal need for support in that area. A 5 to 7 is a moderate need for support, and 8 to 10 is a high need for support. So that just kind of gives you a little orientation. But then the actual functional scores, I think one of the questions that might come up there is, how did we arrive at these? Where do these come from? And so these are an algorithm-based assessment. And we're trying to sort of look at these key root disturbances, these functional imbalances. And so it's based on the biomarkers that are listed underneath the score. So you can see there for oxidative stress, we're looking at cysteine, cysteine, lipid peroxides, 8-OHDG, things of that nature. And it's a 2-factor weighted algorithm, which, what does that mean? So the algorithm is weighted based on the severity of how abnormal the biomarker is, and it's also based on the strength of the evidence for how that biomarker relates to the category. And so that's ultimately how this algorithm is working and how we generate the score, for those who want to know the inner workings of algorithms. So underneath, as I mentioned, we have the biomarkers listed out that play a role in that functional imbalance score, and they have these little icons next to them. They're these green circles, red, yellow triangles. And so what are those about? Those are the actual results. Those are the patient results. So if you actually flip to the latter portion of the test and look these up, you'll see, oh, a green indicates that the patient had a normal result. A red triangle indicates it was outside the reference range, or what we call outside 2 standard deviations. And a yellow indicates that the result was in the borderline category, and up, down just corresponds to whether the analyte was high or low. One other thing to keep in mind too is that an NA is essentially telling you that for whatever reason that analyte was not run. So if you notice that, that'll tell you kind of why we don't have any information for that analyte, unfortunately. And if all the analytes within a pillar say NA, then the actual functional imbalance score will say NA as well. So just keep that in mind if you notice that on a report. So, I mean, let's talk a little bit more about these categories. Oxidative stress. I mean, many of us know a little bit about oxidative stress. We've heard this term. We're talking about free radical damage, right? We're talking about how individual free radicals have the potential to damage cell membranes, DNA, fats, protein. And in the literature, oxidative stress is correlated with so many different clinical conditions. But I think, primarily I think about cardiovascular disease risk, certainly metabolic dysfunction, and obviously cancer risk as well. And if you take a step back, when you think about oxidative stress, I just pulled this article because I thought it was interesting. Oxidative stress has been theorized to be part of the aging process. And you can see here, oxidative stress results from an imbalance between reactive oxygen and oxidative stress, reactive free radicals, production, antioxidant defense, and is primarily involved in the aging theory. In particular, what they're now calling oxy-inflammaging hypothesis. So I just thought that was kind of interesting because, yes, oxidative stress is correlated with certain clinical conditions, but it's also, this is what we're talking about when we're talking about signs of aging as well. The next pillar is mitochondrial dysfunction. So this might be a little bit of a newer concept to some out there, but mitochondrial dysfunction is becoming more and more of a hot topic as it relates to all types of clinical conditions. The mitochondria, if you remember back to kind of biology class, mitochondria are those little power plants within every cell, and their duty is to make energy for the cell. And so as that power plant starts to become less efficient, that's what we refer to as mitochondrial dysfunction. And if the power plant isn't making as much energy, then you can see how that's going to have a major impact on how well the cell's able to function. And so overall, as a concept, mitochondrial dysfunction is associated with cardiovascular disease risk, diabetes, insulin resistance, mood disorder, chronic fatigue, cognitive decline, so many clinical conditions we see underpinning there is a problem around the mitochondria and mitochondrial dysfunction. And then going back to this concept I was saying earlier about aging, this one paper I thought was really interesting because they said that chronic disease and aging is essentially 4 things: oxidative stress, mitochondrial dysfunction, inflammation, and metabolic dysfunction. So right there you can see, okay, we are giving you an assessment for oxidative stress. We're giving you an assessment for mitochondrial dysfunction. We're also giving you an assessment for need for inflammation support based on the omega imbalance score, which is taking into account the overall balance between things like omega-3s, omega-6s, what is the breakdown of the omega-6s, which we'll get into a little bit, and it's a good indication for potential inflammation in the system. The next pillar is the toxic exposure pillar, where we're really looking at just environmental exposures like heavy metals, plastic, petrochemicals, things of that like that. And then methylation imbalance is the last pillar, where we're looking for evidence of poor methylation cofactors or problems around the methylation cycle. And if you have a lot of evidence that that might be a problem area for a patient, you could certainly consider following up with a methylation panel. And then if you are used to using the GIFX stool profile, what we try to do is kind of align the orientation. So you start to become familiar with the look, feel, and how to kind of read through a report and how to synthesize that information, and hopefully how we've been able to synthesize the information for you. So that takes us to the second page, which is the nutrient need overview page. And on this page, we have all of these nutrient needs separated into categories: antioxidants, B vitamins, minerals, etc. And I think first it's important to take a little bit of a gestalt approach and say, okay, what are the main headlines? Where is everything trending for the antioxidant section as compared to the B vitamin section? Because that's going to tell you, if I'm really starting to have to be selective about my interventions, where am I going to get the biggest bang for the buck? Where should I be focusing based on the overall categories of these nutritional interventions? Similarly, the algorithm here, the nutrient need, that green, yellow, red slider is a 0 to 10 scale, and that's an algorithm derived score, just in the similar sort of way that we talked about on the front page with the functional imbalances. Then we have the daily recommended intake, the DRIs, which are they're kind of provided just for information. The next section is the suggested recommendations based on the results of the algorithm. And one thing to know, if you're not familiar with running this test, is that those are actually adjusted for age and gender as well. So those are recommendations that come and are based on the overall nutrient need evaluation. Now, those are, again, just suggested recommendations. They're based on the results of the test. And certainly you know your patients better than we do. So we provide this last column, provider recommendations, where you can actually synthesize the information and then say, okay, here's what I'd actually like you to be taking. Because again, you know the case history, you know the clinical presentation, and you're going to have the ability to kind of take this information and figure out what are the appropriate recommendations. Towards the middle bottom of this page, we have the GI support section, which is broken down into digestive support or enzymes, and the microbiome support section, which is also, we kind of think of, we say probiotics, but certainly prebiotics would fit into that category as well. Similarly to like with digestive support, enzymes could help, but maybe something like a betaine HCl could also go a long way for certain patients. If you order the vitamin D add-on, that would also appear on this section as well. And then at the bottom of the page, we have the amino acid recommendations, which are based directly on the measurement of the amino acids. So if somebody had low amino acids, it's going to spit out a recommendation milligrams per day. Not only is that helpful, but it's also helpful to look and say, what's the overall protein status of this patient? How well are they digesting and absorbing protein? And so if I see a lot of zeros there, I'm not as concerned about somebody's protein or amino acid status. If I start to see a lot of numbers throughout that bottom half of the page, then now I'm starting to ask questions about how much protein they actually eat, how well they're digesting and absorbing protein, and what's their utilization of the amino acids as well. So then the next page are called the interpretation at a glance pages. We've got several of them. And what we've done here is just kind of repopulated the results of that algorithm for each nutrient, but we pair it with a lot of information about that nutrient, such as what does this nutrient do? What's the function? What's the cause of deficiency? Why might someone end up with a deficiency of that nutrient? What are the complications? What are the clinical presentations or symptoms that might be associated with an inefficiency or a deficiency? And lastly, food sources of the nutrient. And so these pages, I think, are really helpful in explaining the results of the test to the patient, because you can see the score right there. And then not only that, you can even go through and circle underneath each nutrient. Okay, I want you to really focus on getting these foods, right? You can almost start to create a little bit of a diet plan based on their results, and it's going to help them understand why you're wanting them to eat this way, right? Why you're wanting them to support with these nutrients, because this is the results of the test. And truth be told, once we get past this page, we start to get into the actual analytes of the test, and it gets into a little bit of biochemistry. So sometimes patients start to glaze over a little bit. So I think this is a really nice, important teaching tool to explain the results of the test to the patient. So from that, we get into the analytes, starting with the organic acids. And it's important to make this distinction, I think, that the latter half of the test, everything we're about to talk about, is what we measured, it's what we assessed. And it's the data that we use to generate the information on the first half of the test, the functional imbalance scores or the nutrient needs. Those are all based on the rest of the test, which starts with the organic acids. So what are organic acids? Well, we consider them to kind of be like metabolic byproducts or end products. They're made in lots of different metabolic processes. They're kind of like these intermediary steps of biochemistry. And I think one of the biggest power of an organic acid assessment is that they give indications of needs for vitamin and mineral cofactors. And oftentimes, I think maybe even more specifically about the B vitamins. So we have them here grouped into various sections based on their clinical utility, and we'll start to kind of go through some of these groupings. But I'd be remiss if we didn't start with this biochemistry here, the Krebs cycle page that might give you some horrifying flashbacks to biochemistry days, or maybe you're like me and you love getting into this stuff. But I want you to understand kind of the power of how these organic acids are used, and that's one of the reasons we have this listed here. This pathway chart allows you to visualize backups in cellular metabolism. And so what we're looking at right here is cellular energy production. We're looking at macronutrients at the top, ultimately turning into energy. And so we're saying, can you see anywhere on this page that there's a backup in the pathway? And what are the nutrients that might alleviate that problem? Because we want to make sure the cell is producing energy, and this is where it's taking place. So here's an example, because not only is it telling you whether the Krebs cycle is functioning well or there's problems with cellular energy production, it's telling you about nutritional needs. So here's how we're really looking at this. If we take this example of beta oxidation, fatty acids at the top are converted into acetyl-CoA by beta oxidation. But as you can see there, it requires magnesium and vitamin B2, right? And so if there's a cellular insufficiency in these cofactors, what can happen is that instead of fatty acids turning into acetyl-CoA, you'll see they spit off into adipic acid and sucraric acid. So elevations in these two markers might be an indication for needs for magnesium and vitamin B2 support. So in this way, we're kind of looking at this page as where are the backups and what is that telling me about nutrients? So let's go through it a little bit. If we look at the top, we have fatty acids, carbohydrates, proteins, and we're seeing how those flow down into acetyl-CoA. But ultimately, there's a lot of nutrients that are needed. You see some of the B vitamins there, you see magnesium as well. And so we're trying to say, okay, is that part of the process working very well? Then from there, I think another interesting thing is we have this area called ketogenesis, which is saying, well, acetyl-CoA can go through a step called ketogenesis, which results in the production of beta-hydroxybutyric acid, which is a ketone body. So keep this in mind. If you have a patient who's on a ketogenic diet, which is certainly popular these days, you might see elevations in this ketone body, beta-hydroxybutyric acid. If they're not on a ketogenic diet, or maybe they're not doing a lot of strenuous activity and exercise where they might be producing ketones, this marker can also tell you about how their blood sugar is being managed, because the more ketones we produce in a setting of adequate glucose intake, that's going to tell me about potential insulin resistance and maybe worsening glycemic control. So there's a little bit of a clinical pearl there around that biomarker. Then from acetyl-CoA, we come down into this citric acid cycle, and this just kind of spins around and around, and we're looking for backups in this particular pathway as well. You can see all the vitamin cofactors listed out there and how they might relate to how this backs up. But at the end of the day, all of these processes are primarily important because the way that they feed into this electron transport chain. This is where the magic happens. This is where the cell actually makes energy in the form of ATP. And we've got a couple analytes listed there. We've got CoQ10, glutathione, lipid peroxides, 8-OHDG, because the electron transport chain generates a lot of free radicals, which is where we might think about lipid peroxides and 8-OHDG, and it requires a lot of antioxidants, which is why we think about things like CoQ10 and glutathione. So there you go. There's a little bit of a basic biochemistry walkthrough. And now you're able to see how we're taking this information of what's happening intracellularly, right? And not just intracellularly, but inside the mitochondria, and using that as information to say there are potential nutrient needs on board. So then we actually have all the organic acids listed out. And we have them broken up into these main categories. We start with malabsorption dysbiosis markers, work our way into vitamin markers, neurotransmitter markers. We'll kind of go through these individually. But I wanted to spend a second talking about how these analytes are actually depicted. So the red area on each one of these analytes is corresponding to being outside reference range. The green area is saying that's kind of our sweet spot. That's optimal. It's within 1 standard deviation. And the yellow is kind of what we consider borderline. It's in between 1 standard deviation and 2 standard deviations. So that's to just give you a little bit of information on what these analytes are depicting. So if we start with the malabsorption markers and the malabsorption dysbiosis marker section, the malabsorption markers tell us a little bit about how well certain amino acids are being absorbed. And if they're not being absorbed, they make their way down the GI tract to where they become fermented and turn into these products like indole acetic acid and phenylacetic acid. So if you start to see elevations, it's suspicious that there might be some malabsorption going on. The next group is bacterial dysbiosis markers, which are things made by bacteria in the gut. And a lot of times they're fermenting things like dietary phenols, flavonoids, berries, cherries, things like that. So that's just a little tidbit. If you have a patient who's maybe doing a smoothie every morning or they eat a ton of berries and cherries, that could play a little bit of a role because the more dietary phenols they have, maybe we're seeing these breakdown products and these fermentation products. But in general, if I start to see trends of higher amounts of these dysbiosis markers, it's suggestive to me that it's kind of like where there's smoke, there's fire. If you see a lot of bacterial products, then it's suspicious around a potential dysbiosis or maybe even a bacterial overgrowth. And last, we have this section of yeast and fungal dysbiosis markers, which we do have a new marker in this section, D-arabinitol. And D-arabinitol is a really great marker for Candida specifically. Arabinitol is made when Candida ferments arabinose in the GI tract. And I think about Candida albicans, tropicalis, maybe a couple of the other ones. But in general, you know, if you're suspicious of a yeast overgrowth, a fungal overgrowth in the GI tract, you certainly might want to consider a stool testing to confirm any sort of suspicion of both fungal or bacterial dysbiosis. Okay, the next section is cellular energy and mitochondrial metabolites. And we kind of went over these, right? We talked about these on that biochemistry page. They're just listed out again here in a list format. There's a couple additional ones that I think are interesting to just keep an eye on. The first one is this alpha hydroxybutyric acid. And I think this is a really interesting biomarker. This can tell us about the overall metabolic health of a patient. It's been correlated in the literature with poor lifestyle habits, things like smoking, alcohol intake, even sedentary lifestyle, because it actually is increased when there's a metabolic imbalance and an energy imbalance within the cell. And so it can be an indicator of oxidative stress and metabolic dysfunction like insulin resistance and worsening glycemic control. Another one here is beta-OH beta-methylglutaric acid, which is part of the HMG pathway. And so if we're thinking about the HMG pathway, it makes me think about one thing I would say is statins, right? Because statins inhibit the HMG pathway. And we always give, or we recommend supplementing and giving CoQ10 if somebody has an inhibitor of the HMG pathway. And so similarly, this biomarker, when elevated, is showing that there's a backup in that HMG pathway, and that might be an indication of a need to support with CoQ10. The next grouping of markers in the organic acids are the vitamin markers. They're so named because they're telling us a lot of information about specific vitamin needs, and I think in particular the B vitamins. And these subheaders kind of even tell you what we're using them for. So we have these groups of branch chain catabolites, and in parentheses it says these tell us a lot of information about B1, B2, B3, alpha lipoic acid. Then we've got methylation markers, which we think about folate, B12, and biotin markers. So this grouping, again, plays a strong role in the B vitamin overall recommendations. And here's an example of how it works. Methylmalonyl CoA. Okay, this is just one analyte, one marker in the system. And so methylmalonyl CoA ultimately turns into succinic acid down here, but it requires B12 to do so. And if within the cell there's not adequate B12 to complete this process, it will instead turn into methylmalonic acid. So by that logic, if you have a high amount of methylmalonic acid showing up in the urine, it's a really good indicator that there's not enough vitamin B12 in the system to allow this normal conversion to take place. That's why it's a functional marker for cellular B12 status. And there's a lot of data out there to suggest that it's probably a better marker for B12 status than even something like a serum B12, because this is telling you how is that B12 actually being utilized, and is it enough? Is there enough within the cell for this process to take place? Similarly, marker called formiminoglutamic acid, or FIGLU, is a marker for cellular folate status. You see that THF there, that stands for tetrahydrofolate. And so I think about dietary folates in this circumstance if you have a higher level of FIGLU. And lastly, things like branched chain amino acids, these all can turn into, here's the branched chain amino acids, valine, leucine, isoleucine. These turn into what's called these alpha keto acids. And over here on the right, you see all these vitamins listed out here: B1, B2, B3, B5, lipoic. A lot of things are required to actually start to use these alpha ketos for energy down in the Krebs cycle. A lot of things can go wrong there, and so you might see some backups in this pathway, and that's an indication of needs for those nutrients that are listed there. So you can look at these pathways to get a sense of how all of this information comes together to tell us about how the patient may need more B vitamins, more antioxidants, things of that nature. But again, they also have information about clinical aspects and direct clinical conditions, such as like the neurotransmitter metabolites. So here, we're certainly utilizing these markers for needs for nutrients, such as the kynurenine markers, which tell us a lot about needs for B6. I'll show you that in a second. But even the catecholamine markers, which come from things like dopamine, epinephrine, norepinephrine, can certainly give you a little bit of information about how much catecholamine is being produced in the system. And lastly, we have the serotonin marker, 5-hydroxyindoleacetic acid, which I think is kind of interesting because, you know, when you think about serotonin, do we really think about how serotonin, 95% of it is being produced in the GI tract? So yes, if a patient's on an SSRI, if they're on 5-HTP, very common to see an elevation in this serotonin marker, but also because so much serotonin is produced in the gut, then when people have a high level of this, I always ask about what their gut function is like. Because remember, what serotonin does in the GI tract is it stimulates motility. And so people who tend to have 5-hydroxyindoleacetic acid elevations, they tend to be a little bit more of the patient who trends along with a more looser stool, or even, you know, often diarrhea. So our IBS patients and maybe IBSD specifically. So keep that in mind as a little bit of a clinical pearl too, because I think sometimes we forget that. Just to dig in for a minute, not to scare you off with the kynurenine pathway, but this is kind of an interesting little area where the kynurenine pathway starts with tryptophan, which is an amino acid at the top, when it ultimately turns into NAD, nicotinamide adenine dinucleotide. And you can see there's B6 kind of listed all throughout this pathway. So it's a heavily B6 dependent pathway. It's why it tells us information about needs for B6. But there's also this concept called tryptophan steal, where if you have a lot of oxidative stress and maybe inflammation in the system, instead of tryptophan turning into serotonin, which is important for mood, it can actually go down at higher amounts, higher degrees, to make this nicotinamide adenine dinucleotide. So that's something to keep in mind as well. Here's just a little creation of the catecholamine pathway. The only reason why I'm showing this is also remember that the catecholamine pathway requires some nutrient cofactors such as iron listed here and tetrahydrobiopterin, which we tend to think of having an integral relationship with the methylation pathway. So that's one thing to keep in mind, and certainly because epinephrine and norepinephrine turn into some of these metabolites, an overproduction of those catecholamines, adrenaline in particular, might result in higher levels of some of these things like vanillomandelic acid. Another section we have listed here are toxin and detoxification markers. And so we start with pyroglutamic acid, which is responsible and part of glutathione recycling. And then a couple things listed here that relate to just environmental exposures. Alpha keto phenylacetic acid, you can see in parentheses, says from styrene. And styrene, think styrofoam, but not just styrofoam. It can be lots of different types of plastics, plastic water bottles, maybe someone's, heating up their lunch in a plastic tray, things of that nature. So think about that from a plastic exposure. And then the next one, it says from MTBE in parentheses, which was a gasoline additive. And so I tend to think of that as maybe being a problem around water contamination. So there's just a couple things there from an environmental exposure standpoint. The next page we look at is oxalates and oxidative stress. We'll briefly talk about these new oxalate markers and get into it so you understand what these oxalate markers are all about. So oxalates it's a general term for things that can form oxalic acid and might contribute to kidney stone production. Keep in mind these can originate both from our diet and regular processes in the body. And what is their clinical utility? Well, here's what's called the glyoxylate pathway. I'm not going to go into it in any detail, but it's there for reference if you want to kind of dig in, and that's your your area of interest. But the oxalate biomarkers we're measuring is glyceric acid, glycolic acid, and oxalic acid. And these oxalates provide insight into abnormal metabolism of that pathway I just showed you, which can result in higher levels of oxalic acid. So what I think of generally is that the oxalates certainly are important in people with recurrent kidney stone risk, because high levels of oxalic acid are a strong risk factor for kidney stone development. But there's also a good amount of evidence to say that increased levels of oxidative stress and or metabolic dysfunction, like insulin resistance, diabetes, things like that, can also increase the production of oxalic acid, which is why clinically it's very common to see a higher proportion of our diabetic patients, our people with insulin resistance, to have higher risk for kidney stones. Again, oxalates come both from internal and external production. It's about 50-50 really. So glyceric acid, just real quickly, it's commonly seen and studied in a few rare inborn errors of metabolism, but it has been correlated with some interesting clinical conditions like rheumatoid arthritis, schizophrenia, and bipolar. Because this is a vitamin B3 dependent pathway, it might provide additional evidence for the need for vitamin B3 overall. Glycolic acid is also seen in some rare inborn errors of metabolism, but it also can be produced under oxidative stress. Just what you're looking at here on the right-hand side is the bottom, glyoxal can turn into glycolic acid in the presence of oxidative stress, or actually is coming from oxidative stress. So that's something to keep in mind with glycolic acid. And the biggie is oxalic acid, because this is the one that we really think of being associated with kidney stone risk. And again, this can indicate a high need for a high need for things like vitamin B6, but it also can come from increased oxidative stress. So keep that in mind. And certainly the diet plays a role there too. We can get a lot of oxalates in our diet, but there's a lot of factors that actually help us break down oxalates, including our microbiome health. Oxidative stress markers we have listed out next. Glutathione, our main primary antioxidant, CoQ10, and then on the right-hand side, oxidative damage, lipid peroxides and 8-OH-DG. So, looking at oxidative damage on the right, just to distinguish these two markers, lipid peroxide is oxidative damage to cell membranes and fats, whereas 8-OH-DG is oxidative damage to DNA, which is certainly not something we want to be doing a lot of. And then on the left-hand side, we have these two very important antioxidants, glutathione, which is our system's kind of major antioxidant, internal antioxidant, and CoQ10, which is very important in cellular energy production. All right, so moving from the organic acids to the amino acids, just remember that you can look at amino acids in two different ways on the NutrEval, either via the plasma or the first morning void. And clinically, when I'm thinking about amino acid interpretation, what's the overall trend? You're going to have a little bit of interpersonal variability, but if I draw a line down the middle of this reference range, where are all the analytes primarily falling? Are they falling down that red line, or are they maybe trending a little bit low or trending a little bit high? So this gives you an indication of dietary protein intake and how well the patient's digesting and absorbing protein. The non-essentials reflect dietary intake for sure, but they also can reflect needs for cofactors, because The non-essentials can be made out of the essentials, but only under the right conditions, only when there's adequate nutrients like B vitamins and minerals. So that's one thing to keep in mind too. I think one of the questions is, well, then can we discern whether somebody's amino acid status, is it derived from how much they're eating versus utilization? What's really contributing here? And that's where we have these dietary peptide related markers. These give me a general indication of protein intake, and specifically meat protein. So 1-methylhistidine is derived from chicken, turkey, fish. 3-methylhistidine is derived from red muscle fiber, maybe potentially red meat intake or muscle turnover related to exercise. So 3-methylhistidine is kind of interesting because it can actually tell us if somebody's maybe even a vegetarian, they're not eating red muscle fiber and you see it high, it could be coming from their own endogenous catabolism of their skeletal muscle tissue. So in general, I think, what's the trend of these dietary peptide related markers, and how does that correlate to their amino acid status? If they have high levels of dietary peptide related markers, but their amino acids are still low, that's telling me the patient's probably eating actually a fairly robust protein diet, but they're not digesting and absorbing it very well because their amino acids are still kind of lackluster. So that's another indication of whether is this amino acid problem based on intake versus digestion and absorption. Have some additional amino acid markers here, metabolites, some additional markers that relate to needs for B vitamins, these urea cycle markers that provide an overall dietary protein intake aspect, and glycine serine metabolites, which are a couple pathways that really relate to needs for magnesium, and some information around methylation on the test. Then we have the essential metabolic fatty acids. These are the fats, right? And this is just telling me what was the balance of fat in a patient's diet. And it's a red blood cell analysis, which gives us a good window and kind of the steady state intake of dietary fats. It's reported by weight percent, which is kind of telling me it's more about balance, right? It's looking like a big pie chart. What are the percents of omega-3s compared to the percent of omega-6s? So by looking at percent, like again, you're looking at a pie chart breakdown. Each section has individual fatty acids, and then at the bottom, an overall percent for that category. So you see percent omega-3s. So that allows you to compare what's the percent of the omega-3s compared to the 6s, the 9s, the saturated fats. And then lastly, we have a section of cardiovascular risk, which is super important. We'll talk about the omega-3 index here in a second. The omega-3 fats, right, we know, or most of us know, these are oftentimes coming from intake of cold water fish, maybe flax, chia, walnut, or certainly omega-3 supplementation. The two big ones are EPA and DHA. If you look at any fish oil, those are going to be the ones that are listed on the back that you're kind of interested in. And if you add the EPA and DHA, you get this omega-3 index, which is probably one of the most, I think it's probably the most important marker on this page, because the omega-3 index has been really well researched to show that lower levels are associated with cardiovascular disease risk. So overall, you really want to make sure that omega-3 index is up into the yellow, certainly, but hopefully up into the green. And from there, we've also got omega-9s that come from things like olive oil. We've got saturated fats and an entire breakdown of the saturated fats. We also have omega-6 fatty acids listed out here as well. And just to dig into the omega-6s real quick, not all omega-6 fats are made equal. I think we think of omega-6 as being all pro-inflammatory, perhaps. But keep in mind, these actually flow downstream one into the next, starting with linoleic at the top, which turns into GLA based on that enzyme circled there, delta-6 desaturase. We actually supplement with GLA, right? And we think of GLA as helping with reducing inflammation in the system. But your body can make it internally by all of those nutrients that are listed there, B2, B3, B6. You see, there's just a lot of different nutrients required to make GLA, and ultimately dihomogamma-linolenic here, which is a major anti-inflammatory omega-6. One other thing on this page that I think is interesting is the trans fats. We certainly always want to keep an eye on whether a patient is consuming trans fats, trying to limit that as much as possible. And then the last section on this report is the elemental markers. Elements are measured in different matrices. You can see listed out there plasma, whole blood, RBC, and we're trying to say what's the best matrix for that nutrient. We certainly know that RBC, magnesium, and potassium are more of a reflection of dietary intake as compared to like your serum magnesium, potassium. But the direct measurements, another thing that's really important, the direct measurements play a strong role in that overall assessment for the nutrient, but it's not the only factor. So what do I mean by that? Well, we measure magnesium here and we say, okay, that's going to give me some information about magnesium status. But when you look at page 2 and say, what's this patient's overall need for magnesium? It's not just based solely on this marker here. It's not based on one analyte. All of these are multiple analytes that come together to generate recommendations. And so, yes, the magnesium that we measure here in RBC plays a strong role in the overall recommendation for magnesium, but it's not the only factor. Toxic elements are measured in whole blood, and these provide a window into exposure. I don't think of them so much as necessarily being about body burden, because that's going to depend on storage and how often that we're going through detoxification, getting these things out of things like brain, bone. So that's a little bit variable, but certainly exposure. And the reference ranges are based on what's called the NHANES data for at least the lead, mercury, and cadmium. So that's where we're getting those reference ranges. Lastly, we do have some add-on components. We've got a vitamin D assessment, and then we have genomic SNPs. We're looking at MTHFR, COMT, ApoE, TNF alpha, which you've probably heard some of those at least, MTHFR certainly, and so those are available as genomic add-ons. Okay, we've got a case report. Let's do this. 36-year-old female, ongoing fatigue concerns, generalized anxiety, recent Hashimoto's diagnosis, weight gain, family history of diabetes, cardiovascular disease, and tries to eat healthy but struggles with sugar cravings. Does have a morning smoothie, which, as I mentioned before, might be a little bit relevant in a couple sections, and she takes a multivitamin, so keep that in mind. Where do we start? Start on the front page. What are the headlines? Well, the primary concerns here to me are omega imbalance, certainly at a 9. That's not looking very good. Oxidative stress, and then mitochondrial dysfunction seems to have some trouble spots as well. Secondary concerns, toxic exposure, and methylation imbalance. So already you're getting a sense of, okay, we need to work on inflammation. We need to work on antioxidants and oxidative stress, and that's going to also help us work on mitochondrial dysfunction. But can I support with some mitochondrial nutrients as well? Second page, look at the groupings. Lots of needs for antioxidants here, right? And it's specifically things like alpha lipoic acid, but glutathione, plant-based antioxidants. Also, big time recommendation around essential fatty acids, okay? So that's another thing as well. And then let's look at the data. Let's look at the test. Starting with the oxidative stress mitochondrial dysfunction page, we're seeing elevated levels of adipic acid and subearic acid. Remember, I mentioned when magnesium and vitamin B2 are inadequate, then this will ultimately not go straight down into beta oxidation, but it'll turn into these analytes, adipic acid and subearic acid. So when we see high levels of that, we think about magnesium, vitamin B2, but also carnitine. This little blue tube here is actually referring to the carnitine shuttle. So when we think about supporting the mitochondria, carnitine becomes a big one. Low levels of pyruvate and lactic acid, what might that be telling me? Well, we know that carbohydrates require magnesium right here to turn into pyruvic acid. And the fact that these are both low might be another indication for needs for magnesium. And then lastly, we've got these problems around the electron transport chain, CoQ10, glutathione, lipid peroxides, 8-OHDG looks okay. Just real quick glance at the organic acids and a few of the highlights here. A few elevations in the GI section in the malabsorption dysbiosis markers, but most of these are kind of trending in the green. So, I might follow up with clinical presentation, and then if I have additional suspicions, a stool test would probably be a good indication there. The vitamin markers look pretty good over here. We're seeing a lot of greens, a couple in the yellow, glutaric acid. Those are actually, interestingly, another indication for vitamin B2. And we mentioned that already with the mitochondrial support. Neurotransmitter metabolites down here look okay for the most part. And then the toxin and detoxification markers, now we're seeing some issues. Pyroglutamic acid is high, which is talking about glutathione synthesis. She's got some environmental exposures in the form of styrene and MTBE in the borderline section. So again, that's why we're thinking antioxidant support, oxidative stress, mitochondrial dysfunction. Oxalates look overall okay, but her glutathione is trending a little bit low here at an 874. And because of that, perhaps, we've got oxidative damage on board, lipid peroxides. And that's oxidative damage to fats. And so that's going to, again, refer back to the need for antioxidant support in the form of things like glutathione and also maybe some of the other antioxidants, our vitamin A, our vitamin E, things of that nature. Looking at the amino acids, we have essential amino acids okay. You know, there's a few that are dipping down into the low area. We've got non-essential amino acids also kind of trending on the low side. So maybe an area of questioning. The dietary peptide related markers, like I said, if you want to compare somebody's dietary intake to their amino acid status, look here, look at the bottom right. Those look okay as well. You know, they're not all below detectable levels. They're not all shifted all the way to the left-hand side. So, you know, I might inquire what the overall protein intake is, but this might actually be more of an indication for just some digestive support to help make sure that the protein this patient's eating is resulting in adequate amino acid levels. EMFAs are fats here. Look at the top left, right? The omega-3 fatty acids are really low. This overall percent omega-3s is in the red. EPA is actually below detectable levels. DHA is low as well. And that omega-3 index here at the bottom right is at a 2, which is not great. So certainly I'm thinking about omega-3 support. She's actually got a fair amount of omega-9s on board, so maybe she's doing a lot of olive oil. Saturated fats down here at the bottom left, percent saturated fat actually right down the middle. So she's making up for her omega-3s in the form of omega-6s, because if I look at the bottom of this omega-6 category, this is a little bit on the higher side. Trans fats look okay, oleic in the green there. And if I look at how these omega-6s on the right page here are being metabolized, there might be some problems here. We start with linoleic acid at the top, which is high. Then we go to gamma linolenic, which is borderline high, but still not high. And then all of a sudden, dihomo gamma linolenic is normal. So you can kind of see with each step, we're getting less and less concentration. So to me, as this is just not flowing downstream very well. So what's that telling me? Well, these enzymes are not doing this conversion very well, and that might be based on some of the nutritional needs here. We talked about magnesium, we talked about vitamin B2, you see those showing up again here. Lastly, actually has high magnesium and potassium on this test, might be based on the multivitamin, but a little bit of a lower zinc copper, right? Copper and zinc are on the lower side too, but the toxics do look good. So overall, I think the big thing here, like we talked about, oxidative stress and omega imbalance. So certainly an omega-3 fish oil could be recommended. I would go with a higher dose to raise that omega-3 index. Maybe a broad spectrum antioxidant thing, something that has going to support glutathione production. It's got some NAC in there, the N-acetylcysteine, it's got glycine, and then mitochondrial support. We talked about carnitine and vitamin B2, magnesium. Even though the magnesium was a little bit on the higher side, if she's taking it in the form of the multivitamin, I'd probably keep that going. And that's what I have for the case. We have additional resources because I know I blew through that like super fast, but we've got this awesome NutrEval Metabolomics Plus support guide, which has over 1,000 references in it. It's a really great resource. We've got, of course, additional LiveGDX webinars, always our ongoing medical education consults. And lastly, we have the Lab Report podcast where we actually dove into some of these topics like mitochondrial dysfunction, oxalates, electron transport chain at greater detail. So if you want more info, you can go there as well. And I have 5 minutes for questions.
All right, that was a wonderful presentation. Hopefully, everyone has several notes, and hopefully you all are enjoying and loving the redesigned, reimagined NutrEval like we are. So I just want to start off with this question first. Can you please repeat the general rule for using supplements prior to testing?
Sure. So you can do two things. You can either have the patient discontinue, and that's going to give you more of an evaluation of the patient at baseline. That's going to tell you, based on their diet, what are their nutritional needs. Or you can choose to have them remain on their supplements, and that's going to give you more information about how that system is actually operating under the influence of those nutrients. So it's kind of up to the clinician, and again, what's the question you're asking? What's the answer you want?
Perfect. So if you could also review, why would an individual, or what clinical cases would you consider ordering the NutrEval with first morning void amino acids versus the NutrEval with the plasma amino acids?
Yeah, so keep in mind that when we're looking at the plasma has a longer half-life than the urine does. And so when you're looking at the plasma amino acids, I'm thinking that as being more of a reflection of the last week or so. It's kind of more of a steady state. When I'm looking at the first morning void, that has much more rapid turnover. Maybe it's giving me a window into the last couple days of their protein intake. And so there's that one distinction there. If you want to know what is the overall amino acid status of this patient, then a plasma, I think, is a nice way to go. The thing that's on the FMV is that because we recommend the patient always just eat and consume their regular diet. You know, we don't make any alterations, like what's the information about how they're regularly eating. And so with the FMV, it can also give you a little bit of information about vitamin, mineral, nutrient cofactors, because, you know, that when we're looking at it, we're essentially saying how well are these amino acids being utilized and metabolized.
I also think about using plasma amino acids for individuals who had GI surgeries, who have eating disorders, who just don't have that like steady diet. I also think about utilizing it for mood disorder patients as well. So absolutely wonderful.
Yeah.
So what about for those individuals or clinicians who don't have the option of drawing blood? You mentioned really briefly the Metabolomics Plus profile. Can you talk a little bit more about that, please?
Yeah, for sure. So if you don't have access to phlebotomy, we've got the Metabolomics Plus, and that is a base panel that has add-on options. So the base panel Metabolomics Plus is the organic acids, the amino acids, and then a couple of the oxidative stress markers, and that's just a urine test. And I think the great thing is to that you can add on the essential metabolic fatty acid blood spot, and that's going to give you all that additional information around omega-3s, omega-6s, and so you really can almost get all the information from the NutrEval on the Metabolomics Plus with the essential metabolic fatty acid blood spot, and that's all can be done at home. So that's really, really great if you don't have access to phlebotomy.
Very good. And the last question, somebody was just wondering about the 5-HIAA marker, which is the metabolite of serotonin, and they're wondering, other than 5-HTP and SSRIs, what might be some other reasons it could be elevated?
So, I mean, those are the biggies, but if it's elevated, like I said, I certainly would be looking at their gut, because 95 or so, I don't know if there's full total agreement on whether it's 90 or 95% of it is coming from gut-derived serotonin production, but because that's such a big process and so much of it is coming from the gut, when we're looking at it in the urine, then it's a really great reflection of gut production of serotonin. And so I'm always looking at dysbiosis if it's elevated. I'm always looking at what's their motility, what's their prebiotic, probiotic, their fiber intake, all those things related to gut health. And because, like I said, serotonin in the GI tract stimulates motility. And so these patients, it's even documented in the literature that there's a strong correlation between urinary 5-HIAA and rapid transit.
Wonderful. I'm just going to look briefly. I don't see any additional questions, and it is almost at the top of the hour. So I think this is a perfect place where we can conclude. So we're just going to end our question and answer period there. But for additional educational materials, please go to our website, www.gdx.net, and you can also contact client services. So we not only offer complimentary appointments with our medical education specialists to answer questions related to testing and also choosing the right test, but also reviewing the patient test results. Also on the website, you will also notice that we have a support guide for the NutrEval as well that is listed in the handouts that you can download prior to the end of this session. I'd also like to encourage everybody to register for the upcoming webinars we have on our website at www.gdx.net. And if you have not already checked out the podcast, what are you waiting for? The lab report focuses on functional integrative medicine, specialty testing, laboratory diagnostics, and natural therapeutics with hosts Dr. Patty and Dr. Michael, and an assortment of wonderful, phenomenal guests from different industries. So I hope you all will go ahead and join and listen to and subscribe and all that good stuff to our podcast as well. But thank you, Dr. Chapman. That was a great presentation. And we really appreciate your time because we know how busy you are.
No, absolutely. Thanks, everyone, and hope everyone has a great St. Patrick's Day.
Bye.